All right, number 13 has a lot of quadratics, and we need to factor and then flip the second one. What's the expression for dividing fractions? Keep, change, flip. Keep the first fraction the way it is, change the division to a multiplication, and use the reciprocal of the second term. Okay, so we need to factor everything. Negative first means double negative in the answer. Factors of 8 that equals 6. And then this one right here is a plus and a minus, which is a plus and a minus, so it has to be a positive 4 and a minus 1. So you get a positive 3 left over. Negative first means double negative, so 1 and a 2 or 2 and a 1, doesn't matter. And then the top one here, negative first means double negative, 3 and 4. All right, so that's gone. That one's gone. That one's gone. X plus 4 over x minus 3. All right, next one. Change gears to an addition problem. Addition problem means you're going to need like denominators so you can add them together, so you need an LCD. So the LCD would, these are two factors that have nothing in common, so they need to multiply by each other to get the LCD. So we're going to end up making equivalent fractions by multiplying them by what they factor they don't have. So that's how I remember how to do that. So 4x minus 2, x minus 2, x minus 3 is the LCD. And then this plus here, and then it's a negative 3x. I should probably put that negative in there. Negative 3x minus 3, okay? That's how I do those. If you want to step through that a little slower, you're going to have to make equivalent fractions and another equivalent fraction with a plus in the middle that have the same common denominators here and here, and then add what's on top, and you're going to get that, okay? So this needs to be distributed carefully. Okay. And then combine like terms. So x plus 1, okay. And then this is still x minus 2, x minus 3. And the order is unimportant. You can have x3 and then it's minus 2. You can also have that put back together. I can't imagine it's necessary, but just in case. Okay. I think that's fine though. All right, this one has a lot going on, but I bet this is the same thing over here. Negative first is a negative negative. 48 would be a 6 and 8. 6 and 8 added together is 14. So yes, these two factors are in that denominator, so the LCD is this one here. So all of these need to be multiplied by what they don't have. So this is going to need to be x minus 8. This is going to be x minus 8. To make equivalent fractions, we got to multiply by the same thing in the fraction, right? It's not the same thing here and here. It's the same thing here and here, okay? To make the denominator this. So this is going to be x minus 8. And hang on, and then 5 times x minus 6, and this is all going to be over the common denominator, and then this side is going to stay the same. It's kind of an odd looking one, but that's the way you do that. I'm just going to do this just in case I need to, because this is that. All right, now for the odd maneuver here. Let's see. This is, well, let me finish distributing. This is going to be, x squared minus 8x plus 5x minus 30. Combine like terms. So this side's going to be x squared minus 3x minus 30. And this side is going to be negative 4x plus 12. And if you can picture multiplying this whole side and this whole side by the LCD again, it's going to cross out. Do it over here too. All right, so you actually literally get left with this problem right here, okay? So if we're heading towards a quadratic, after I did all that, I still have an x squared, so I want all of the terms all to one side, so I can see if it would factor. So I'm going to keep my x squared positive. So let's move this 4x and this 12 this way. Sorry, this looks quite messy. X squared plus x minus 42. So that is going to factor. This is a long one. Hang in there. X plus minus, to have a leftover 7 and a 6. So that means the zero product rule. X equals negative 7 and 6. And way back up here, I don't know if you can see this anymore. Let me get all this stuff out of the way. Way back up here, we had denominators here, and we need to make sure that none of your solutions make any of the rational expressions undefined. So since this 6, if x equals 6 and we put it in there, 6 minus 6, that's going to equal 0. So that's going to make that a problem. So that makes that can't be the answer. So that is definitely extraneous. An extraneous solution. And we're not going to include it in our answer. So our final answer is x equals negative 7. Okay? Because that we can use. All right, let's look at this one here. This says find the range and domain. For these, I like to make all the ordered pairs. So this is going to be negative 1, 3. I know there's no dot there, but it goes up, hits it, and come down. So I need to know what that point is. That's going to be my maximum. So that is 0, 4. And down here, this one is going to be the point 2, 0. All right, so when we talk about the domain, we talk about the lowest x that we can have, kind of going this way and this way, right? So the farthest one this way is a negative 1. See, this negative 1 is the farthest, this line of this graph goes to the left. So that's a negative 1. It's on a negative 1 with a solid dot. So it's on a negative 1. All right, and then how low can it go? How high, sorry. We're talking this way and this way. That's the low end, is a negative 1. The high end is this point right here that goes all the way to a 2, a positive 2, and it's an open circle, so that's a soft bracket. Okay, put the range in another color. So the range, we're talking about the y's, right? So the lowest y we have is right here. and that was at an open circle, so that's a soft bracket, okay? And then the highest y is this 4 right here, and I'm going to put a dot there because it's not an open circle, it's a continuous line, so it's got to be solid. So that's my domain and range. So it goes from here to here is the range, and from here to here is the domain. Okay? The domain for the function, except for x where x equals. I don't know what that means. But I know that it's a rational expression, and that denominator cannot equal 0. So to find what x can be and not be, okay, you need to set that to equal to 0 and solve for x. So that would tell us what x cannot be. So for x, if that makes any sense, for x, that reduces by 2, that's going to be 17 over 2, or it doesn't say if it wants a decimal. 8.5 would be something that x could not be. I don't know if they want to put it like that. So so think of the domain as all x's would work there except for 17 over 2 or 8.5. Okay, I believe that's what that's looking for. All right, 18, we're just filling in these numbers for x. This is the name of this function is f, so function of x is the following, and then we're going to put in different x's. So everywhere there's let's try to make these neat. I like to show my work. Show the substitution, please. Everything times 0 is 0, so this is going to be a negative 8. Put in the positive 2. This is going to be 6 times 4 plus 6 minus 8. 24 plus 4 is 30 minus 8 is 22. All right, the negatives, notice I put things in parentheses. I still want to do that, especially for the negatives. So this is going to be 6 times 4 is still going to be 24, even though it's negative. But then this is going to be a negative 6. So that's going to be a 10. And then this one's a little strange, I know. Just stick with the plan here. All right, a negative x times negative x is a positive x squared, so 6x squared. This right here is going to be a negative 3x and minus 8, and that's all you can do with it. Okay, let's try number 19. Y varies directly with x. If you remember your terminology, varies directly. I always remember directly means divide, so this would be divided by that. So we always are solving for k first when we do these, so y varies by x. I always take that step to write that down, and then I substitute in what they told me these stand for, and you solve for k, which is going to be 8. Okay, then it gives you another situation. All right, and k, this is still the formula, but now I know that k is 8, and y is now unknown, and the x is now 5. So the proportions are still the same, so we're going to just solve for y. So we're going to clear our fraction by multiplying both sides by 5, so y is going to equal 40. That's how I do those. This one varies inversely. What varies inversely? The intensity varies inversely of the square of the distance. Okay, so varies inversely is a multiplication problem for k. Varies directly is a division. Varies inversely is a multiplication. Okay, so what was the first thing? The first thing, when it varies directly, goes on top of, in the numerator. When it's multiplied, it's the first thing of the product. So I'm going to use an I for intensity. Multiply that by the square of the distance. Square of the distance, you can use D, you can use any letter that springs to mind. I think the examples we used in class were an R, but we can go with the D. Square of the distance of the light source. Okay, so there's my formula. All right, step one is to plug in the I and D they give you and find K. So here's one here. There's the I is 0.24 at a distance of 5 meters, which is going to be squared in the formula. 0.24 times 25, sorry, I can hardly read that. So K is going to equal 6 apparently. And then you want to set this up again with K as 6, and then I and D squared, giving the new information. So this one says find I, so I don't know what I is. And then it says 8 meters, which is a distance, okay? So we want to put that in as 8 squared. So 6 equals 64I. Just, it looks weird if you don't kind of write it on that side. And then you get the I alone on one side. Okay, so I is going to equal 6 divided by 64. And it says round to 3 decimals. So 6 divided by 64 is 0.094, because that's 0.09375. So we want to go there. Okay? And then I think the next one is going to take a minute. So let's do that on the next video.